Okay, so now we're going to be discussing the laws of exponents and logarithms. I'm going to just go through the laws like themselves first, with no questions or no examples. And later on, I'll do like a video with a bunch of different examples and questions, okay? So this is for the laws of exponents, yeah? So first of all, let's say you have a to the power of n multiplied by a to the power of n. Yeah. If you have two different, if you have two numbers, yeah, two of the same numbers, yeah, you have a, and they are both raised to the power, raised to a power, or have an exponent, and are multiplied by each other, then what you can do, since they have the same base, you can take that number and then raise it to the power of both exponents added to each other. Yeah, so this is the first rule. This is called the product rule. Yeah. Then you have the quotient rule. You have am is divided by a to the power of n, right? So if here it's going to be m plus n, the exponents are going to be added to each other, what do you think is going to happen here? They're going to be subtracted, yeah? So you take both exponents and you subtract them from each other. So this is the quotient rule. Then you have what you call the power of a power rule. So a to the power of m, for example, to the power of n. Yeah. Now, if you have a power like a number that is raised to a power and then is also raised to another power, like outside on the bracket here, then you can multiply both of these exponents together. So you can take a and raise it to the power of m times n. Then you have the power of a product rule. Yeah. So if let's say you have ab is to the power of m, then what you can do is actually separate these terms and raise both of them to the power of m. Yeah, so you can have a to the power of m multiplied by b to the power of m. Yeah, this is the same thing. Yeah. Then you have power of a quotient rule, so a divided by b, let's say for example, is raised to the power of m. If this is, wait, this looks very bad. A divided by b, all to the power of m. Now in this case, what you can do is you can distribute this exponent on both numbers in this fraction here. So you can have a to the power of m divided by b to the power of m. Now usually this is useful when you need to simplify it as much as possible, when you need to simplify whatever is in your bracket as much as possible to get rid of the exponents. Yeah. Then you have the zero exponent rule. Anything raised to the power of 0 is going to give you 1. Yeah. Then the negative exponent rule. So if you have a negative exponent, yeah, then what you do is you put this base over, you take this, yeah, and you find its reciprocal, yeah. So you write it in a reciprocal form, a to the power of m, but then that negative exponent will be gone, yeah. So you don't have a negative exponent anymore, yeah. So a to the power of negative m, you do the reciprocal of this, so it'll be 1 over a to the power of m, okay. Then finally, you have a to the power of m divided by n. So this is the fractional exponent rule. In this case, what you're going to have is a fraction, yeah, sorry, a root, yeah. So you're going to do the base to the power of the number on the numerator, yeah, on your fraction in the exponent, and then the denominator is going to be the number on your root. So over here. Yeah. So these are the laws of exponent. So these are exponent rules, each one that you need to know. And as I already said, I'm going to be going through these in more detail with some questions to come. Okay. So now let's move on to laws of logarithms. Yeah. So let's move a little bit to the side over here. Zoom in. So first of all, let's say you have log am plus log a n. Yeah. So here you have the same bases for your log. Yeah. So you have log a and log a. So you have the same base. Since you have the same base, you can then therefore take m and n and multiply them by each other. So you can say log base a m times n. Yeah. So this is how you can rewrite it. For the subtraction rule, you can say log a m minus log a n. So if here we multiplied it, then here what do you think we're going to do? We're going to divide it. So it's going to be log a m divided by n. Yeah, so this is what it would look like. Then you have the power rule. If you have something like log a m to the power of k, yeah, then you can take this k and place it in the beginning here. So you can multiply this entire expression by k, yeah? So it will be it will be k times log a m. So this is how you can rewrite it. And this is crucial for when you're simplifying a lot of your, like sometimes it will tell you like simplify this expression or whatever, and you have a number that you really need to get rid of. Sometimes you need to use logarithms, or an exponent that you need to get rid of. Sometimes using the logarithm rule. This logarithm rule specifically is going to help. Yeah. Then you have the inverse logarithmic property. So if you have log base a and then a to the power of k, for example, then of course the base a and a here will cancel out. These two are going to go, and then you're just going to have log, and this is just going to equal to k. Yeah, because the entire expression of log is just going to be canceled out. Yeah, you're just going to have k in the end. And finally, the zero rule, log base a of 1 is equal to 0. Okay, so those are the logarithm rules or laws of logarithms. Yeah, so that's that. So we're gonna go and we're gonna do a bunch of algebraic questions later for these laws, both exponents and logarithms. So yeah, all right. See you guys in the next one.